Hi everyone, my name's Anne-Katherine Burns. I'm a rising second year grad student in the physics department. And today I have a quick video for you guys on some vector basics. So if you've been having trouble with vectors, this is the video for you. All right, let's get into it. All right, so as you can see, we have an XY plane here, and I am drawing the vector that we're going to be looking at in red. So all the vectors that we're going to deal with in this class are going to live inside the XY plane. They could be in any of the four quadrants, but they will all have X and Y components. So right here, I am drawing the X component in blue. So that blue line you see along the X-axis is the X component of our vector. And now I'm going to draw the Y component in green, and I've tried to kind of color coordinate everything, so hopefully that'll help make things really clear. So we have our X component in blue and our Y component in green. And now I'm just going to label the lengths of our X and Y components. So the length of the X component is 2. And the length of the Y component is 1. And I'm not quite to scale here, so bear with me. Okay, so as you probably guessed, we're going to be using our trigonometric functions to solve for the direction and magnitude of the vector. So SOHCAHTOA is a super helpful little device for remembering what the different trigonometric functions are. As a grad student, I use it to this day. And it basically just reminds you of the information that just appeared above. So sine theta, for instance, is equal to opposite over hypotenuse. And opposite, in this case, corresponds to the Y component, which is that green arrow, and hypotenuse is the vector in question, so that is the red arrow on the plot. So first we're going to try to figure out what the direction of our vector is. So the direction is that theta angle that you can see on the plot just below the red arrow. And we're going to be using our tangent function to figure out what theta is. And the reason that we're using tangent is because we already know our opposite and our adjacent values. So opposite is just the Y component, which is equal to 1, and adjacent is the X component, which is equal to 2. And once again, I am color coordinating, so that hopefully is really clear where I'm getting those values from. All right, so we now know that tangent theta is equal to 1/2, and we can use our calculators to just invert tangent theta. So sometimes it's called arctan, or sometimes it's tan to the -1, depending on your calculator. But all you're going to do is you're going to do tan to the -1, in this case, of 1/2, and that is going to give us our value for theta. So arctangent of 1/2 is equal to 26.57 degrees. And we can also convert degrees to radians. That's something to really be aware of. Your calculator probably has a degrees and a radians setting. So yeah, our value of our angle is 26.57 degrees, which is also equal to 0.463 radians. And now that we figured this out, we are finished. We have found the direction of our vector. So the way that this might come up in a problem is the problem might say something along the lines of the X component is equal to 2, the Y component is equal to 1. What is the direction? And we just found that. Theta equals 26.57 degrees. Awesome. Okay, so now we're going to solve for the other piece of the vector, which is the magnitude. So all vectors have both direction and magnitude, and the magnitude is just the length of the vector. So in the same way that the length of the X component is 2, the magnitude of our red vector is what we're going to be looking for right now, and it's just the length of that red vector. And as you can see, I'm a little slow on my color coordination here, but there we go. Okay, so we've already used tangent to solve for our direction. So now we are going to use our sine function to solve for the magnitude, which is the hypotenuse. So what we're going to do is we're going to write down sine of theta, which we've already solved for. We know that theta is equal to 26.57 degrees. So sine of 26.57 equals opposite over hypotenuse. So again, looking at our plot here, we know that opposite is just our y component of our vector. So that is equal to 1. And then our hypotenuse is what we're solving for. The hypotenuse is the magnitude of the vector. So writing down 1 here for our opposite, and then we're solving for our hypotenuse. Okay, so sine of 26.57 is something that you can again just put into your calculator, and that is going to be equal to 0.447, and I'm rounding here, but 0.447 equals 1 divided by the hypotenuse, which I have abbreviated to be h because, as you can see, I'm running out of room. And then I just do a little algebra by multiplying h on both sides and dividing both sides by 0.447. And I found that h, our hypotenuse, is equal to 2.236. And we're done. That is the magnitude of our vector, 2.236. And as you can see on the plot, it kind of makes sense. It looks like the length should be a little bit more than the x component, and it is. It's just a little bit more. So our magnitude, aka our length, aka the hypotenuse, equals 2.236. And we also found the direction, which is 26.57 degrees. And we are done. So we took x and y components and found magnitude and direction.